So first, a little bit of housekeeping. Everyone, please open your chat box to communicate and see what we will be putting into the chat as well while we're speaking. Also, please use the Q&A function to submit questions, as I mentioned previously, that you would like for Dr. Kabay to answer. As mentioned earlier, for those of you who may not be able to submit questions via the Q&A function, please click the raise hand icon. Our team will enable your audio to allow you to verbally ask your question. This event is being recorded and posted to our Privacy and Security Brainiacs YouTube channel. And you can see that in the chat box. Noah will be posting it there. Attendees, please submit your questions using the Q&A option. I wanted to repeat that based upon a lot of other Zoom events that I've done. That's a question that's asked often at the beginning, so I did want to repeat that again. So the purpose of our event today is to ask Dr. Kabay questions about anything related to his new book, his new online secure coding course, anything related to cybersecurity, privacy, and compliance topics, particularly those that are related to secure coding and development. Please go ahead and you can start entering your Q&A questions now and throughout the rest of the hour. Now, we received a lot of questions, many questions ahead of this event, and we want to get more now. What do you want Dr. Kabay to answer about secure coding and related cybersecurity and privacy? Also, your certificate of attendance. I know some of you are attending. You want to get your CPE for attending, which makes sense, of course. Those answering a poll question early in this hour, and then the other poll question that occurs at the end of this hour will be sent a certificate for 1 hour of CPEs or CEU credits to apply to your applicable certifications, with the information on the certificate that most types of certifications require. Those will be sent to you around 7 days after this event. So now I am so delighted to introduce our speaker for today. Dr. Mish Kabay is here with us, and he began programming when he was very young in 1965, and from 1978 to 1979 Mish created compiler code, and in the 1980s Mish worked at Hewlett Packard Canada as an operating systems and database performance specialist. Dr. Kabay also ran a consulting firm specializing in computer performance. Dr. Kabay's biography, really, it could fill a thick book, actually. The very first information and computer security conference course that I took in my career was a 2-day class that Dr. Kabay taught in 1993 at the Marriott Wardman Park Conference Center in Washington, D.C. And I learned so much while I was there, and I was really inspired by many of the topics that he covered and also the many use cases that he presented. And I am confident that everyone attending today and watching will also learn so much and be inspired throughout the rest of this hour. You can see more about Dr. Kabay on his professor page on our Privacy and Security Brainiacs site, privacysecuritybrainiacs.com. Please see your chat box for the URL that goes directly to Dr. Kabay's page. So, Dr. Kabay, welcome to our Ask Me Anything event. Thank you.
Thank you so much. And I just wanted to make sure that everyone knows that in 1993, Rebecca was 8 years old.
Thank you for that. I appreciate that very much. So here's the first question that we have for today, and it has to do with basic understanding of secure coding. So, Mish, what's the focus of the secure coding course that you provide?
It's so simple. Don't have mistakes in the code that's being written and maintained. That's the goal is as few as possible and preferably none.
Preferably none. Well, based upon that, Noah, could you please go ahead and post the first poll for our attendees? And while Noah is posting that, Mish, I do want to ask you a little bit beyond that because you know what I found over the years, and something that some of you may not know, I was an adjunct professor under Dr. Kabay, who is the director at the Norwich University in the Master of Science in Information Security and Assurance program for 9.5 years. And when it comes to like errors in code, a lot of people don't know really what that means because a lot of the programmers since then that I have interviewed to see if I wanted them to do work for me, when they say they don't have errors, they think strictly about the syntax of the code or just making sure that the code runs. So, it will be interesting to see what that means. But when you're talking about secure code, you're going way beyond that, right?
Yes. Imagine if somebody told you that they designed your car so that it would run perfectly, but only at 32 and a half miles an hour on a 4-lane highway going north. Hello?
So there's no
Okay,
errors,
is
but
that perfect design? No.
right,
The
right.
issue is that mistakes in code can include the unexpected, the dangerous, and the silly. For example, one of my favorite examples of a mistake in code is that I'm not making this up, automated crappers in Scotland. The little houses where people can go in. They
Yes.
locked, they locked the users inside because there was an error in the code.
Oh,
I think that's a pretty good example of a mistake.
that would be an error, and that would be definitely a physical security problem.
Oh dear.
So, Noah, hopefully all of you attending have answered the poll one. And again, to get your certificate, you need to answer both polls. So, Noah, can you read to us the results of our poll so far?
Yes. So 20% of people thought that secure coding means to keep code secret, and the remaining 80% thought that secure coding means to minimize errors in code used in the real world.
Okay. What do you think, Mish?
Well, we have to be clear. Keeping code secret can be a perfectly legitimate goal. Proprietary code may have to be protected. However, as we will discuss, I believe we have a discussion coming up about that. There's a whole area of code called open source coding. It's the opposite of secret. It's completely public, and we'll talk about security issues with open code, but definitely we just want to minimize mistakes. Code
Well,
should do what it's supposed to do and not other unexpected results.
absolutely. And that I think this is a great poll question too, to kind of point out who will benefit from the
Yeah,
secure coding course before we start getting into the specific topics.
yeah.
So who did you write your course, uh, who you had in mind when you created that
It's
course?
it's interesting because it's got a component that not everyone will expect. Clearly, the course is designed for designers of code, the analysts, the people who are um, showing programmers the requirements, the functional requirements, we call that, of the new code or of the modified code. And the second group is the people actually dealing with the code, the programmers. Now, those people have to work clearly with the designers, but there's a third group that I think really needs to be aware of the issues, in my experience, and that's the managers of the programming groups. Not all of those managers have actually been designers, or programmers. So in those cases, I think it's very useful for them to grasp what their employees are grappling with. Instead of simply saying, oh, well, I expect this done in 2 weeks, and the programmers are practically fainting, saying, oh my goodness, that's not easy. I mean, we have to think through the design and discuss it thoroughly to make sure that we're going to be coding something that will work. So I think those three groups make sense. The designers, the programmers, and the IT managers, the programming group managers, they will benefit.
And I think that's great. I think two others that would probably benefit too are one, IT auditors
Oh,
who have to audit code sometimes. And then number two, the actual cybersecurity and information security team who are interacting with the programmers, right? So I think
there's
those,
one other group I think that we're going to be addressing in a different course that will follow. You and I are working on um, the quality assurance and patch management, software quality assurance and patch management course, which will be a follow-up to the secure coding course. It's nearly finished, and we're looking forward to presenting that. And the QA people already are typically programmers.
yeah,
People who move into quality assurance typically have years of experience because you need that experience to be able to design the tests and analyze the code and identify sources of error. So it all makes sense. Secure coding and then quality assurance really fit nicely together, and I'm sure we'll see people from the first course who may want to take the second course on quality
absolutely.
assurance.
Hope so. Hope so.
Yeah.
So I want to briefly, though, give you an opportunity to mention your new book because you have a
Um,
newly published book, The
yeah.
Expert in the Next Office Tools for Managing Operations and Security in the Era of Cyberspace. So I know you've written other books. How many books have you now published, written and
You know, you
published?
you asked me that, and I think it's six. I wrote a textbook around 1995 called the NCSA Guide to Enterprise Security.
Ah,
And then, oh, and that was interesting. That book was actually used in defining the CISSP, I found out.
really?
The team used that as a resource. So I was kind of nice. And then there's multiple editions of the Computer Security Handbook by Wiley, the fourth, fifth, and sixth editions. Now that I'm retired, I've handed it over to other editors. But those books have proven to be the most widely used security books in the world.
The
And
Brainiacs.
when I took over, I doubled the number of pages, went from 550 in the third edition to 1100 in the fourth, and then doubled it again. We ended up with, like 76 chapters and 2,200 pages in two volumes. And then I wrote some little handbooks for my students at Norwich. It's about this big, a little handbook on personal privacy and how to respect the uh, privacy of other students and avoid obvious mistakes.
Very
So that,
important. Well, what motivated you then to write this book after taking a few years off of writing books, it sounds like?
yeah. Well, I looked at my collection of roughly 2,000 articles that I'd published when I was a columnist for Network World and wrote for Computer World and the HP 3000. I used to be with HP, and I wrote columns on security and operations in the HP 3000 magazine. In fact, the title, "The Expert in the Next Office,"
Yeah.
was the first essay I wrote that I published in 1986 in the Interx magazine for HP 3000 peoples. And I integrated that essay into the book, but it's about how dangerous it is operationally to have users depending on informal support from their colleagues, the expert in the next office. No documentation, no record of what's going on, and it can be a disaster when the boss says, you're working 80 hours a week, but you're only accomplishing 30 hours of my work. What are you doing? Well, I've been helping the other people in the department. It's stopping. And suddenly the tech support ends, and the real tech support gets a flood of demands that they didn't expect, and there's no documentation of what was said. So anyway, to answer the question, I decided all of that material could be organized into a useful, I guess I would call it a tutorial, a series of informative chapters on how to run information technology with an attention to operations efficiency and security. So that's why I put them together. I
Well,
must tell the viewers, however, and this is where I should turn bright red. Apparently, when I submit when I submitted the manuscript, I didn't notice, ironically, that the chapter on secure coding was only the first few pages.
uh-oh.
So the publisher and I have been talking about this, and we're going to issue a second edition. And people who buy the first edition, I'm going to have to provide them with the rest of the chapter. So maybe some of the techniques that I applied in secure coding could have been appropriately applied to my own work in writing the book.
Yes. That's a good
Yeah.
point. It applies to not only digital, but also the physical of
Oh
having the physical book. But yeah.
boy,
And I know you have a lot of fun stuff in there too.
I do. I had to fight for this. I have been a graphic designer since I'm not making this up, since I was 7 years old. I learned to touch type when I was 6. And when I was 7, I put together a 1-page, 3-column little newsletter called the Jolly Fellow Club News. And I always would have a drawing in the upper left-hand corner that went with the magazine. So in my teaching, I use images and cartoons all the time. I like to keep my students chuckling and being stimulated. So I actually got permission from the publisher to include a usually funny cartoon in the beginning of every single section, not just chapter, section of the textbook. So it's got all kinds of jokes and puns and stuff like that. I have um, license that I pay for every year, very modest fee, for clipart.com that has 26 million images with keywords. So it was very easy for me to make up cartoons
So you have a lot
that
of
would illustrate the
cartoons.
points. It was fun.
Wonderful.
I had a good time.
Sounds like it. It sounds like it. So that sounds great. I want to get into now the actual concept of secure coding. So I think a lot of people, when they think about secure coding, they think, well, they want to get right to the meat of the heart of the topic, right? So what is the most important part or aspect of secure
Yeah.
coding?
Well, I've mentioned this in the initial comments. Something surprising, I think, to many people. I firmly believe that awareness of secure coding principles by managers of the programming groups or the IT groups, managers who may not, in fact, have a highly technical background, is terribly important to prevent unrealistic demands for speed on the developers. There is research that has long been established in the world of programming. Somewhere on the order of 80% of the development time should be in design, testing, user acceptance, actually testing with users to see if the code is acceptable, easy to use, doesn't cause mistakes, and the like. Well, if managers think, oh, I can just say, you have to have this ready in 2 months, when in fact, the complexity of the system, the nature of the user community would realistically demand 6 months we're going to have problems. We're going to see people skimping on the design discussions. They're going to have resistance when someone says, look, I was looking at this design, and do you realize that we could run into a problem? And the answer is, oh, no, we don't have time for that. We're in a rush. That's not acceptable. So ironically, I think that having enough understanding of the various levels of complexity of design and implementation and testing of code to ensure security. And security, by the way, remember what we mean by security. There are 6 elements that are defined as the Parkerian hexad. We're talking about preserving confidentiality, control, and we won't go into all of the details, but availability, utility. These are fundamental elements that we have to protect. We can't just create a code and say, oh, well, it'll be good enough. Well, no, it has to be as good as possible for the purposes that we are designing the system. And I believe we are going to talk about some of the different systems
Yes.
and aspects that we have to consider.
Absolutely, because that's a nice segue into the next question. We had someone who wasn't able to attend today, but they said, "Well, what's the difference between secure coding for different purposes?"
Yeah.
So, secure coding practices vary depending upon the context where the actual code is implemented. And we have several developers and coders and software designers who registered to attend live or are watching the recording. I think it's important that they understand about the differences in coding practices based upon the context of use. What are your thoughts?
Very much so. Every every system has specific goals that it must achieve. Those goals may vary from implementation or customer group to group. And in fact, one of the issues that I do discuss, it's a startling case, but it's a real case. In 1986, I was called by a software company who had billed a customer. All of these are 1983 to 1986 numbers, so multiplied by roughly 5 to get an idea of how much it's worth in today's money. And these are accurate numbers because it was something I remember. They had charged $2 million for development, and they charged $600,000 a year for 3 years. That's 1.8 million. So in all, they had $3.8 million that they had received from the customer for their system. Well, their contract included terms of service or performance. One of the characteristics that was in the contract explicitly said no transaction shall take more than 10 seconds. Sounds good. Yeah, one of the transactions took 43 minutes.
Yikes.
The customer was, as you can understand, not happy and proposed to bill the company $3.8 million as specified in the contract for failure to meet the requirements. Well, you can imagine the initial phone call to this performance specialist and database. And it took me 3 days of analysis. What I did was I measured the activity on the system. We have log files, we have tools that will tell us how much disk I/O, input output, there is, and how much memory utilization there is, and how much CPU memory. Well, it turned out that the 43-minute transaction was spending 23 minutes in disk I/O and 20 minutes in CPU overhead. Now remember, this is the 1980s. These are big, huge mainframe computers, very slow compared to what we're used to. I looked at why there was so much disk I/O and discovered that the designers had implemented a serial search of a data set looking for specific information. Well, it might have worked fine when they had 25 records, but when they had 40,000 records, it didn't work so well. So I redesigned that and explained to them, look, there's this thing called an index where you send, where you index the data in the field in the background, and when you add another record, you update the index, and it takes like takes 2 seconds. And then when you search, you input the search. I'm sorry to be laughing. It just seems so silly. You input the search value, and the index tells you which records. So within a couple of days after I submitted my report, those results had dropped to 3 seconds.
Wow.
Instead of 43 minutes. So I still laugh at that because it just seems so silly that they never did what we call volume testing.
Yes.
Which will be part of my software quality assurance course, is see if it works with real volumes of data, not 25 records that you invented for the preliminary tests.
I think a lot of folks listening might say, well, that doesn't apply today, but it does.
Oh, yes, it does. Of course it does. Where we had tens of thousands of records, now we have sometimes billions of records. And performance is of critical importance, especially if you think about different areas, not just, oh, a human being wants information. What do you think performance does in industrial control systems? Industrial control systems like those that control factories, those that control the electrical grid. Do you really want to have a performance problem in how an electrical grid responds to spikes of voltage from a lightning strike? No.
Yeah, and I might add just one more thing before we go to our next question, but that's so important, the grids and everything that is dealing with so many edge devices that are providing data in to the central processing area. So it feeds directly into your point, I think, because what if that data is being collected by traditional or original Bluetooth? That's going to be a lot different than something that's low energy Bluetooth, right? The BLE or some other type of transmission. So we're getting so much more of that. So anyway, I think your example, even though it was from the 1980s, it's even more important today because we have so many more computers out there. They're just many different types. Um, Here's something too. A lot of the developers who have come to us when we've been looking for help with our platform, we talk about APIs, application programming interfaces. And a lot of times they've said there aren't any secure coding issues with APIs. You know, that's the look I get. So please explain what critical secure coding needs are often overlooked by developers for APIs.
What we call usability of code can provide errors of usability or defects, can cause significant delays or even blockage of user performance. Now, look, if we have an application program interface, that by definition implies that there are going to be users interacting. It's not just a machine to a machine. There are human beings involved. In my experience, one of the most serious errors that I have seen over and over in the application program interface is that the API does not provide adequate information to the users when they make mistakes or even to provide instructions. I taught my students for decades. I started teaching programming in 1980. I taught my students for decades. Always ensure that there is an easy way to get an answer on what is appropriate, what is correct, why a mistake has been made. Don't simply say, error 341. Are you kidding? Error 341? That can be very useful for the program design team. It's totally useless for a user. So the error messages not only must be plain user language. Where I come from in Canada, that would mean providing both English and French versions available on demand, but also that there be additional information. An obvious way of doing that is you put a question mark symbol, and anytime there's a request for more information, the user clicks the question mark, and it gives context-specific information, possibly with additional levels if that's what the user wants. That's an example of usability and security in application program interfaces. So how's that?
I think a lot of folks don't think about security being, communication to the end user, but it does.
Definitely. Think of the mistakes that
Yeah.
we can avoid if we provide adequate documentation on demand. And
Yes.
by the way, just another quick note, for many years I have objected to providing user manuals on paper. Why? Because, first of all, they have to be loose leaf and 3-ring binders because they're changing all the time. And you get a notice that says, please replace page 351 by page 351A, 351B, and 350, and the user has to put it in, which they don't do for 3 months. And the consequence is that they're deprived of adequate, up-to-date information on how the system works. So application program interfaces, documentation, that's part of effective design and programming and implementation and management.
Yes, absolutely. Well, now let's go to a different context of use. So this would be for website pages. So you go to somebody's web page, you go
Yeah.
to the home page, you get redirected and so on. And I know this is just an ongoing problem with every website, I think, with having an error just show up from on the web page. And I know a lot of the developers who've spoken to me, they immediately start talking about the type of code that they're using. Well, it's HTML that's causing this problem. It's PHP that's causing this problem. But really, isn't it how it was designed, regardless of the code?
Yeah, very much so. When you mention the websites and critical security coding needs, what instantly comes to my mind is one of the worst errors in the design of a web page or a website. And that is to allow a user to enter data into the search field, into the input field, without controls. And the example that comes to mind is a real example. What you have to imagine is a website that provides information about an individual using a numerical or alphanumerical code, usually at the end of the URL. So it'll say, HP, and then slash. It might not say user ID, but it would say slash AX34127B9. Here's the problem. If the designers and implementation team don't screen what is being written in the URL, it means that unauthorized entry of some other alphanumeric sequence could result in access to a real record. And I have a real case. One of my colleagues reported with some embarrassment that many years ago, he noticed that when he deleted the entry for himself in a spam bot, it involved a purely numerical sequence, 127359. You know, out of curiosity and without thinking about the law, he entered a different number. Holy cow, it deleted somebody else's record. Well, not satisfied with that and completely ignoring 18 U.S. Code 1030 subsection A, the Computer Fraud and Abuse Act, which prevents unauthorized access to other people's data, he wrote a script. It deleted 20,000 records in the data set because the programmers who wrote the code never checked to see if what was being entered as the delete instruction or a display instruction or whatever was authorized. Unbelievable.
So
Unbelievable.
yes, so that's a very important part of it too. And
Wow.
and I'm just going to give you one really quick example because I have a lot of other questions to get to. But did you read in the news? It was, I think, yesterday I read it, that with Chat GPT, you can actually ask questions embedding code
Wow.
that will then be used to exfiltrate data from others who are using ChatGPT. So there's some errors there that need to be fixed. But
And
I want to go into the portals then, the secured, like when you go to your patient portal online,
yeah,
you're going to a completely different area of the system, right? Because it's behind a secured
yeah.
area, but it's often written in different code like PHP or whatever your favorite is out there that the coders you're using. So, what secure coding needs are needed behind secured portals that are maybe different than those public portals?
Well, and this is very appropriate for your area of work of privacy. The issue is that the code cannot allow unauthorized access to confidential data. And in the United States, we have many laws, but the two most important are the HIPAA, which is the Health Information Privacy and Protection Act for medical records. We also have for educational data, like what you're recording. FERPA, the Family Educational Rights and Privacy Act, or FERPA, makes it a federal crime to reveal information about somebody's educational status, like their transcript, without explicit permission. In Europe, the GDPR, the General Data Protection Regulation, is extremely strict, more so even than in the United States. So when we are designing portals, it's absolutely essential that the functional requirements include an absolute ban on unauthorized access to other people's data. And then we have to implement those very carefully so that any attempt will be caught by the filters that have been designed and implemented to say, hey, wait a minute, that record doesn't belong to the person who is running my session. That's not acceptable. And then there would be a message that can be placed on the screen that says, this is not acceptable. And if it's done more than a few times, it should say, you are violating our privacy regulations. We are shutting you down. That would be an example of a design that would help reduce abuse in such cases.
Absolutely. So a lot of legal issues and then a lot of coding issues that need to be done to support those. I might mention too, there's currently, I'm not sure if I always keep track of the state laws too, but at this point in time, there's 19, some people consider 20, what's called comprehensive privacy laws, state
Mhm.
privacy laws. So those have to be looked at too. But I want to go to something, a practice that I'm seeing a lot more promotion of doing. Our
Yeah.
business leaders are pushing the use of as much low code and no code practices as possible to cut coding time and costs, at least by half. And those practices seem really risky to me. What are some ways to practice secure coding when using low code and no code tools?
Well, it's not going to be pleasing the managers who have chosen those approaches. Let's back up for a moment and say that the low code environments aren't inherently bad. They're systems that use GUIs, graphical user interfaces, to generate the code. So you design, you put up a flow chart, and it will interpret that information as a basis for creating the code. These systems can often offer templates. In other words, examples of the style of code that is appropriate for a given function. Well, that's wonderful, but the problem arises when the standard functions are not sufficient for the security needs of a particular application. Under those circumstances, it's very important that the system's ability to integrate external code be used. It is possible to write the code that we want ourselves using for special functions and designing it to be very secure and then call the routine that we wrote, that we have designed, that we have checked and tested and elaborated on, instead of just assuming that, oh, well, everything's going to be handled okay by the no-code system. That could be difficult because some of the programmers in the team may actually not have written, at least recently or even recently, explicit detailed code to meet a particular function. So it's not that it's inherently bad, but we have to be aware that the requirements of our application may exceed the ability of this system to meet our own specialized security demands.
So that's a very important thing for anybody who's doing development in code to check on. I want to get to gosh, the time has gone by so quickly, but I want to get to AI, to artificial intelligence, because that's something that is just becoming more and more of an issue with regard to coding. So, just for the benefit of our listeners, isn't an artificial intelligence algorithm software code? And if yes, then how can secure coding be fulfilled when creating AI tools? And what differences, if any, are there in the software architecting, the pseudocode, and the coding processes of AI tools and AI generated code?
Yeah, you can tell from my reaction that this is not an area that makes me happy. Artificial intelligence is based on textual analysis, whether it's of a particular natural language like English or French or whatever, or for AI generation of code, the AI system has to analyze existing code and look for patterns, sequences of commands in a particular language, whatever language it's generating, that occur often. Did you notice that I didn't say anything about how it chooses code that is correct?
Mm-hmm.
It just chooses code, it evaluates code based on frequency. This is common in the non-coding world, the AI systems that answer questions for us in our native language are summarizing information based on how often words and phrases and even sentences in the scanned sources come together, and they put them together. Incidentally, in many cases, violating copyright law because they don't have permission to use other people's work in generating their results. But that's a whole other issue. That's cyber law. In the programming, and in the language generation, the fundamental problem, that is not my idea, this is well known, the fundamental problem is that there is no world model. A world model has rules on what is reasonable, what is realistic, what is possible. Some of the most obvious mistakes that have occurred in word generating AI are called hallucinations, where the system will respond to a perfectly normal question like, how are presidents elected in the United States? And you get an answer within 30 seconds maximum. And it says all kinds of good stuff, but it includes the sentence, and presidents are chosen by aliens from Mars. It's just stuck in the middle of the response. Why? Because the engine happened to have seen more than one joke about presidents being elected from aliens from Mars. It has no basis for saying, oh, wait a minute, that's no. That's the lack of world model. The same thing occurs in code. If the code that it is scanning includes mistakes of design or implementation, then the code that is generated may very well include similar errors. That's the fundamental problem of the automated systems. It's not that you have to stop using them, but I would say anyone who uses generated code is going to have to spend a lot of time analyzing exactly what it does, maybe even documenting it because the code may not include comments that explain what's going on, so that later programmers who are maintaining it may be able to fix problems or add functions. It's not as easy as just saying, oh, well, the computer wrote the code for me. That's it. No, no.
Yes, and I would think too, and you'll probably get into this when you do your next course about testing and quality assurance, but
Yeah.
it seems like if you're using your AI generated code, you would have to expand upon your testing and quality assurance activities, especially, what do you think about too secure coding? How is bias and ethics? Certainly, you don't want to have that in there, but does secure coding in and of itself have um, have risks for having bias built in, either purposefully or accidentally, and ethics
I
using
think
and manipulating the code?
we actually have real world examples of where improperly designed artificial intelligence systems have betrayed the prejudices and biases of their creators. The specifics include such things as facial recognition, where it turned out that 90% of all of the samples that were analyzed during the training of the AI had pink skin. And the results have been horrific. There are facial recognition systems that are misidentifying people who don't have pink skin, with the results that the wrong people are being arrested and abused, and it's vilified. This is an example of that problem of the world model. The data that are being used is biased. In programming, everything is going to depend on what code is being analyzed. And that's probably going to be a result of human beings providing access. What if the human beings select code that is already out of date? What if they choose code that already is known to have errors, but the people making the selections are not educated enough to have researched the literature and said, hey, wait a minute, we can't use that code to train our automated code generator. It's going to include mistakes. These are human problems as well as computer problems. The human beings are very much responsible for how these systems are going to generate their results. We have to be aware of that. On top of it, it's going to take a lot of work. Can't be just, oh, well, generated the code. I'm sure it's fine. No, I'm not sure it's fine.
Yes. It, and we're getting close to the end, and I want to get our other poll out there soon. But just as a quick thought, before we push out our next poll, um, I think what you just said is so important. The fact that there's a lot of human activities, human thinking, human logic that still has to occur when you're doing secure coding, even if you're using AI tools and even if you're using other types of tools to help you with your coding. What are your thoughts about that? Just a really quick.
Absolutely. There's no excuse to skimp on the analysis of the code to see, as a human being with expertise, to see if the code that is being presented matches the functional requirements of the system. Remember, I keep using that word, functional requirements, what the code is supposed to be doing. So there's going to be careful analysis of the actual code as part of the software quality assurance of the code that has been generated. We're going to look at limiting cases. We're going to look at unusual inputs, all of the kinds of things we do to check that a system doesn't have unexpected results. It has to have expected results and only expected results.
I think that's something too I've seen a lot. Just, and I'll make one comment and then I'll ask Noah to post the next poll. But I think we've gotten to a point where I've seen so many developers, when I've talked with them, they're just testing for the expected results, right? So if they're only testing for the expected results, you're never going to find a lot of errors that would have occurred if somebody put in something unexpected. Uh,
I think in secure coding, in the design phase, we stipulate limits on inputs and even limits on sequences. And the people who are designing the code, I'm not even talking about quality assurance yet, people who are designing the code must include treatment of unexpected data. The obvious examples, you have numerical input between 100 and 200. Well, don't you think you might want to check numbers that are less than 100 and see that you give a proper error message, and numbers that are greater than 200 to make sure that they don't cause a system crash or a mistake or a security violation of other kinds? That's part of the design and writing phase. You don't even wait for the
yeah.
quality assurance, which is done by a separate team. By the way, I'll say that again. Software quality assurance must be a completely separate team from the design and development team, and they may even have to report to different managers. But that's another issue which we'll talk about in another course.
Yes, because that's really important. Right now, though, it's time for our second and our last poll. So please answer. This is going to be open ended. Please answer this in your own words, and then Noah will read the answers for us without mentioning the person who provided the answer for privacy. So that way you can put whatever you want. But what was the most important or surprising lesson that you learned today? And, we'll give you a few seconds to think about this. I think probably you heard a few things that might be a little surprising, especially about secure coding. But go ahead and enter this to get your certificate and your one CPE. Why we need to have answers to both of these polls. So we do encourage you to answer these. Um, yeah, there's so much I wanted to talk about today with you, but we aren't getting to it. I guess while Noah, do we have all the uh, answers at this point, or do you want to wait a couple of seconds before you read?
We have two more people who need to answer.
Okay, so the remaining two, if you could type those in, and then we will go over them. I'm curious to hear what they have to say, and since they're they will be anonymous on our recording here, and to the other attendees, it will be very interesting. Again, these courses that we're talking about, and also the full classes that are made up of many different courses or classes or lectures, they could fill semesters and semesters of learning. That's for sure.
Rebecca, you and I were chatting about that when I was teaching my security courses in universities. Typically, I had 3 one-hour lectures a week for 20 weeks.
Whoa.
That's an example.
Yes,
There's a
absolutely.
lot of material to become expert in our fields.
Absolutely.
Yeah.
So Noah, why don't you go ahead and start reading some of the answers that people have had, just so we know. And Noah, I don't know if you realize you're on mute right now.
Oops.
All right. So one person said, how eminent and knowledgeable you both are. So the nice response.
Yeah.
That's so nice.
Second person said that Mish is Canadian.
Yes. Well, I'm an American citizen as well.
Someone said that AI adds more to the need for security.
Yeah, I
Yes.
agree.
And the last person said just learning about secure coding.
Good.
Well, thank
Good.
you. Thank you for your
Great.
input today. And thank you again. This has been our very first live event that we've actually hosted. So, and you could probably tell that we still need to work out the fine details. So we appreciate your patience. We appreciate you attending, and we look forward to doing more of these. Please send us information about what you found to be maybe helpful, or suggestions you have for future live events, and we will be very happy to read them. We want to get your feedback. So thanks again for attending. And we look forward to having you attend another one real soon. We'll see how quickly we can get another one scheduled. Thank you all. Have a great evening, and talk to you again soon. Goodbye.